So in this video I want to show you what is the famous QuickSort sorting algorithm. This is one of the most efficient algorithms, so it is a good idea to have a basic understanding of how it works. The main idea in the QuickSort sorting algorithm is to choose one element that we call pivot element, and to put all the elements that are lower than pivot element on the left side of the list, and then to put all the elements that are higher than the pivot element on the right side. So this way the pivot element will be placed in the right order. We still will have two sublists that are actually shuffled, but then we'll repeat the same procedure for the sublists, and because this is actually a recursive algorithm, we'll be able to sort the entire list this way. So let's see how it works. So I'll put this thing here just to remind you that we'll need two concepts: a concept of a left pointer and of a right pointer. Left pointer will point to elements that are actually less than the pivot element. That's why I put the dot below the pivot. And the right pointer will point to the elements that are higher than the pivot element. So we start by putting the left pointer to the leftmost element and the right pointer to the rightmost element. And we choose the leftmost element to be our pivot element. So I'll put it here so we can see it. And then we move to the right pointer and we check to see if it is actually higher than the pivot element, because that's what we expect. And 5 is higher than 4, so in this case we just move the pointer one element closer to the center or away from the end, and we expect the next element 2 to be higher than the pivot element, but actually it is lower. 2 is lower than 4, so in this case we move it to the left pointer, and each time we move element to a pointer we have to move the pointer closer to the center. We expect the left pointer, here the red dot, to point to an element that is lower than the pivot, but we see that 8 is actually higher than the pivot element, so in this case we move 8 to the right pointer, and each time we do that we move the pointer closer to the center. We expect again the element to be higher than the pointer because this is the right pointer, and 7 is higher, so let's move it again. But here we see that 3 is actually lower than 4. In this case we'll move it to the left pointer, and we'll move the pointer one element away from the end. 1 should be lower than the pivot element, and it is. 1 is less than 4. Let's move it then again. 6 should be less than 4, but it is more. So if it's more, we move it to the right pointer, and we move the right pointer away from the end. So we see that the left and right pointer collide in one place. When it happens, we actually move the pivot element to that place, and we end up with two lists that are not ordered, they're shuffled, but the 4 element is in the right place, and that's what we wanted. So we'll now repeat the same procedure for the 2 sublists, and this will be the second stage of the recursive process. So again, we choose the leftmost element to be our pivot element. In this case it is 6. Put it here, and we look to the right pointer. Right pointer we want to contain element that is higher than the pivot element, but 5 is lower, so we move it to the left pointer, and we move the left pointer one element away from the edge. We expect the 7, which is red pointer, left pointer, to be lower than the pivot, but it is higher. In this case, we'll move it to the right pointer, and we'll move the right pointer to the center. 8 is higher than 6, so we don't move it, we just move the pointer. And where the pointers collide, we'll put there our pivot element. So that splits our element into two sublists, 5 and this one. If the sublist contains one element, we can assume that it is ordered. This one contains more than one element, so we'll have to repeat the same procedure. And now we see that we have this part ordered and these two lists unordered. So we put the left and the right pointer. The leftmost element will be our pivot element. Let's put it here. Then we expect the right pointer to point to an element that is higher than the left pointer, but it is not, so we move it to the left pointer. And we move the pointer away from the edge, and where they collide, we move our pivot element. This way we have this part sorted. The only remaining unsorted part is this list. So let's move the left and right pointer. 2 is the most left element, so we choose it to be our pivot element. Let's put it here. Our right pointer, we expect to contain elements that is higher than the pivot element, but 1 is actually lower than 2, so we move it to the left pointer, and again we move the left pointer away from the edge. 3 is in the place of the left pointer, so we expect this to be lower than the pivot, but it is higher, then we move it to the right pointer, and then we move the right pointer away from the edge. In the place where they collide, we move our pivot element, and voila! We see that all the elements are ordered. This is the QuickSort sorting algorithm, and as you can see, the basic idea is not so difficult, and it should be easy to understand, I hope, after watching this video.